The SonicWall Cloud Secure Edge standalone connector enables secure, zero-trust access to private, on-premises, or hybrid cloud applications without requiring traditional VPNs. It's ideal for supporting remote work, cloud migration, and application segmentation. Businesses benefit from enhanced security, reduced complexity, faster deployment, and lower costs, making it a strategic tool for modern, distributed IT environments. The connector is a dial-out component that establishes a secure tunnel to the CSE Global Edge Network. In addition to deploying a connector on a SonicWall firewall, CSE also supports installing a standalone connector on a corporate server. This standalone connector can be deployed in any location with access to your internal services. The illustrated workflow on the screen captures the key decision points and system configuration stages integral to CSE deployment. You can deploy standalone connectors across different environments using various deployment methods available directly through the CSE Command Center. The process involves two main steps: registering the connector in the CSE Command Center and then installing it. The connector needs to be able to connect outbound to the internet. There's no need to open any inbound ports. Ensure that the connector server can establish an outbound HTTPS connection via port 443 to the command center. Ensure that the connector can establish an outbound UDP connection to the Global Edge Network. The connector will select a port in the 21,000 to 59,999 range to set up WireGuard tunnels with the Edge network. Ensure your networking policies allow traffic to flow from the connector server to back-end machines running the applications and services you need to secure access to. We begin by selecting the Create Connector option in the top right corner of the panel. In the first step, we will configure the required parameters via the installation wizard: name, API key, network, and domain. A sample connector name and description have been entered in this example. Next, we will select an API key with a satellite scope for setting up the connector. The two API keys are listed in the Select API Key drop-down menu on the Networks page. Select Install Connector from a list. Alternatively, you can use the option Public IPs and increase connector limit to enable access through your Global Edge private network to public IP addresses or services. Next, we will set the internal network for remote access. To create an address range for the internal network, select Custom CIDR from the list. Next, we will remove the existing RFC 1918 addresses. Then we will enter the customized internal network address range. A sample address range has been entered for the purpose of this demonstration. Select the plus icon to add it. Note that you can also add domains to allow end users to use FQDNs within the service tunnel. The next step is to install the CSE connector on the server. Notice that the connector can be installed on Windows Server, Linux, or a virtual appliance. The connectivity steps and installation instructions for a Windows server are displayed on the screen. You can review the prerequisites for network requirements before installing the connector. Note that the connector supports installation on Windows Server 2022 and above. There are 9 steps to install the connector on a Windows server. Note that the connector for a virtual appliance supports installing on ESXi versions 8.0 or higher. There are 9 steps to install the connector on ESXi as shown on the screen. The first step is to download the OVA file. Then, complete steps 2 through 9 to complete the installation. You can install the connector on Linux via the 2 methods, Tarball or Docker. The connector on Linux supports installation on the following versions: Ubuntu 20.04 and 22.04 LTS, Amazon Linux 2, RHEL 7 and 8, and Oracle Linux 8 and above. You can review the network requirements for connector install. The network requirements and prerequisites for installing the connector on a Linux server include network reachability and supported operating systems. The connector binary can be installed on virtual or physical 64-bit Linux servers. The connector leverages WireGuard to establish secure tunnels. If your Linux version natively supports WireGuard in the kernel, the connector will use that capability. Note that if your Linux version doesn't support WireGuard in the kernel, the connector will fall back to its user space implementation.
Let's go over the steps to install the connector on Ubuntu LTS using the Tarball method.
We've connected to the Ubuntu server, created a directory for downloading the connector binary, and changed to the directory. Next, download and extract the tarball installer. Before beginning the connector binary installation, specify how it should connect to the command center so it can register itself and receive its configuration. This step is done by editing the connectorconfig.yaml file. This file is located under the directory connector 2.0.0. Use your Linux text edit tool to configure the parameters in the connectorconfig.yaml file. Update the parameters as shown in the CSE command center. The next step is to run the setup script to install the connector on the. Notice that the connector is now installed and running. The newly created connector Linux server is in pending status. To update the status, select the refresh button in the top right corner of the panel. The Linux server is now in reporting status. There are 4 potential connector statuses. The reporting status indicates that the connector has reported to the command center within the past 7 minutes and has established a connection with each POP. Partially reporting indicates that the connector has reported to the command center within the past 7 minutes, but it is disconnected from at least one POP. Terminated displays if the connector has not reported to the command center within the past 7 minutes. Pending indicates that the connector was created but has not reported into the command center to receive its configuration. To review the configuration details, select the connector name. Once a connection has been established with the Ubuntu server, you can use the systemctl command. You can manage the connector using systemctl start, status, or stop.